this video, we'll understand about connectivity of graphs and some of the related nomenclatures in that. Connectivity. An undirected graph is said to be connected if there is a path between every pair of vertices, that is, from every vertex to any other vertex, there must be some path to traverse. This is called the connectivity of a graph. And a graph is said to be disconnected if there exists multiple disconnected vertices and edges. For example, consider this graph. It has got A, B, C, D, E, F, G, H vertices. And these are the edges. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges are there. This is a completely connected graph because from any vertex to any vertex, we will be able to traverse. So it is written here, in this graph, it is possible to travel from one vertex to another vertex. We can traverse from B to H, from here to here, like B to C, and then C to D, and then D to F, F to G, and G to H. And we can also traverse like B to A to D, D to F, F to E, E to H. So there is a connectivity possible from any vertex to any vertex. This graph is a disconnected graph because there is no connectivity between D and F. So in this, we cannot traverse from B to H. We cannot, right? So that is disconnected graph. Then let us understand what do we mean by cut vertex. Let capital G be a connected graph. So this is a connected graph. We are calling that as a capital G. A vertex V, small v, is called a cut vertex of G if G minus V results in a disconnected graph. So in this graph, if this vertex D is not there, then it will be called a cut vertex because of that, this has become a disconnected graph. So if I remove this D, then A to D will not be there, C to D will not be there, D to F will not be there. So you will have this as the graph, which is nothing but D minus this vertex D. So here D is called the cut vertex. We will understand now about what do we mean by a cut edge or a cut bridge. Let capital G be any connected graph. This is a connected graph. We are calling this as capital G. An edge E, small e of capital G is said to be a cut edge of capital G if G minus E results in a disconnected graph. For example, A, B, C, D, E, F, G, everything is connected and there is a possibility of traversing from A to G in this graph. So this is basically a connected graph. But if we remove this edge, that is D to E edge, if we remove, or D comma E, if we remove that, what will happen is this becomes a disconnected graph. We call that as G minus of D comma E. So here D to E is called the cut edge or cut bridge. Then the next nomenclature, cut set of a graph. Let capital G, V comma E be any connected graph. Let E1 subset or equal to G. E1 is said to be a cut set of G if and only if deletion of all edges of E1 makes capital G disconnected. For example, we are considering this a graph, a connected graph, A, B, C, D. There are 4 vertices and there are 4 edges. Now, if we remove edges E2 and E3, that means there will not be any connectivity from B to C. There will not be any connectivity from A to C. If we remove that, and we are calling that as E1, a set E1, then G minus E1 will become like this, right? So it is making this capital G to disconnect itself. The next, vertex connectivity. Let capital G be any connected graph, then the minimum number of vertices whose removal results in a disconnected graph is known as vertex connectivity, denoted by K of G. Consider this graph G. Here we have vertices A, B, C, D, E, F, and it is a connected graph. Here, removal of D and A means I am going to remove this vertex D and vertex A. If we remove this A, then there is no B to A, there is no C to A. And if I remove this D, then there is no D to E, there is no D to F. So what will happen? It will become like this, B to C, only this edge will be there, and then F to E to F, this only will be there. Here, K of G is 2 because we removed 2 vertices. Next, edge connectivity. Let capital G be any connected graph. So we are considering this example, A, B, C, D, P, Q, R, S, and everything is connected. Then the minimum number of edges whose removal results in a disconnected graph is called edge connectivity. It is denoted by lambda of G. Here, removal of edges BR and DP results in a disconnected graph. So here, I mean, if I remove this, what will happen is only this will be present, this will be present, because we are removing both BR and DP. So here lambda of G is 2. Again, since we have removed 2 edges, we consider lambda of G as